This is your video to describe how to do basic cost of goods calculations. And as we know, understanding the cost of a product is an important part of product development because consumers first choose to buy a product based off of the price that they're seeing at retail. Nutrition and taste are great, but price is king. So in class we talked about making our smoothie. We had a very basic recipe because I wanted to not dwell too much on the complications behind doing the calculation. I want you to really be able to master this skill set. So we had 3 ingredients going into our smoothie. And as we mentioned in class, your best way to deal with evaluating cost of goods, most important thing is you need to be weighing each ingredient as it goes into your product formulation so that you can have a strong estimate of what each ingredient is contributing to that cost. Now, that said, don't measure a banana with its peel on it. Do make sure to peel the banana before you weigh it. However, this is me making a silly PowerPoint. So, in class we talked about the weight of the different ingredients going into our product. And we had some specific prices that we indicated based off of our retail pricing. So flax seeds we were able to get at $8.99 for a kilo. Milk, $4.27 for 4 liters. It's not that we're putting all of that content into a recipe, it's that we just need to have a strong indication of what our cost is going to be. So what we need to do is not just take that cost, we need to figure out what our cost per gram is. And so if we do the math behind this, our flax seeds, we had 15 grams in our recipe, but our cost was $8.99 per kilogram. We need to go back to what is our package weight. Now, again, these are numbers that I arbitrarily pulled out of the sky. You should be figuring out what indeed is your package weight. Now, this is more challenging when you've got very large quantity, but in the case of our milk, I realize that there may be a density calculation that needs to take into effect with the milk. But for 4 liters, we can roughly estimate it's going to be 4,000 grams. And again, on our banana, it should not be the banana with the peel on. It should be a peeled banana. And so we'll talk on a later module about doing yield calculations on products where you have to do peeling or draining or there's loss of weight during the cooking process. What you're going to do is take the cost of the product and divide it by the weight of the product in grams, and that will give you a cost per gram. And you may be saying, well, wait a second, Amy, you got way too many significant digits. And that is true. I have a lot of significant digits. But if you recall in class, we talked about how significant digits can mean a lot if you are scaling a product from making a single unit to maybe making 100,000 units or 1,000,000 units. A fraction of a penny multiplied by 1,000,000 units can mean a very large sum of money, and that could make payroll for any number of different costs. So how does this fit? I'm going to exit out of here, and I'm going to go into my Excel document here. So this is the formulation sheet that we were working on in class, and you will take a note. I have gone in. This is the formulation sheet. So it's called the simplified formulation chart. Please fill in the date, your recipe name, and a version code. If I am working on a product development project, I need to make sure that I am keeping track of my versions so that, let's say as I'm going along, I think, that recipe that I made back on January 31st, that one was pretty good. And since then, I haven't quite been on track. Let's go back to that. We know which version we're at, and this coding system is consistently used in the industry. So I filled in my ingredient. I filled in my supplier. The more information, the better. So it's not just milk, it's milk 2% coming from Seal Test. It's flax seeds, they're ground, coming from Bob's Red Mill, and so on. The more information, the more we are able to consistently go back and repeat that ingredient. We went from our household measure, we weighed it out, and we were able to then estimate not just estimate, calculate our percentage. So we took each of the weights and summed it down here. I'm going to put this spreadsheet up in Blackboard so you can access it and take a look at the calculations and work them and reverse engineer them for yourself. If we take the value in D9 divided by the total weight of our recipe, that will give us our percent. And I use the percent tab up here so that it's expressed as percent. And again, I'm not rounding away all of my significant digits because, again, a fraction of a percent could mean a huge difference in our formulation, especially when we scale it up. So in general, I always say leave at least 4 significant digits and do not worry about it. I transferred our cost per gram over from the calculation that we did before, and that cost per gram is what we're multiplying against the weight. So you can see that calculation here. Cell F9 multiplied by cell D9 to get our unit cost. And then if we add it up, we note that our recipe from an ingredient cost is going to cost 84.53 cents. And from there, you can take a look at which ingredients are contributing to the cost and make a decision if you need to be reducing cost by a certain fraction. Do you change the percentage of different ingredients? This is a really useful tool, and this is just the beginning of our costing adventures together. These sheets are extremely important, and this is the sort of skill that you want to have a mastery of when you are ready to graduate. Cost calculations are absolutely essential, and cost improvements and cost efficiencies are something that many product developers are dealing with on a day-to-day basis. If you have any questions about this video, you know where to find me. Take care, have fun, fill out some spreadsheets.